gives rise to the specific shapes and functions of proteins. During the 1950s and 60s, discoveries about protein structure forced biologists to confront this mystery. Dean Kenyon believed he could solve it. In his book, Biochemical Predestination, Kenyon and his co-author, Gary Steinman, proposed an intriguing theory. Kenyon wrote, "Life might have been biochemically predestined by the properties of attraction that exist between its chemical parts, particularly between amino acids in proteins."
At the time that biochemical predestination came out, I and my co-author were totally convinced that we had the scientific explanation for origins.
Kenyon proposed that the chemical properties of the amino acids caused them to be attracted to each other, forming the long chains that became the first proteins, the most important components in the living cell. And this meant that life was effectively inevitable, predestined by nothing more than chemistry.
Many scientists embraced Kenyon's ideas, and over the next 20 years, Biochemical Predestination became a best-selling text on the theory of chemical evolution. Yet 5 years after the book's publication, Kenyon quietly began to doubt the plausibility of his own theory.
It was during that whole period of time that my doubts about certain aspects of the evolutionary account became apparent. When coming into contact with a powerful counter-argument given to me by one of my students, and I could not refute that counter-argument.
Kenyon was challenged to explain how the first proteins could have been assembled without the help of genetic instructions. In living cells today, chains of amino acids are not formed directly by forces of attraction between their parts, the scenario Kenyon envisioned on the early Earth. Instead, another large molecule within the cell stores instructions for sequencing the amino acids in proteins. It is called